students, and welcome to your lesson for today. You are one lesson away from finishing Unit 1. Our Unit 1 has been on equations and inequalities. So you went through those 3 lessons last week on equations. And then this week so far we've learned about how you solve and graph inequalities, how you solve and graph compound inequalities. The last thing for us to look at to be inequality experts is our favorite, word problems. So what we're looking at today is how you use inequalities to represent word problems, and then how you can use them to solve our word problems. A lot of the skills and questions in this lesson are going to build on what we already did in our lesson with equation word problems. So you're going to notice some similarities with these problems and those problems. The difference is going to be, today we're looking at inequalities, which if you were here with me, I would ask you, do you remember what an inequality is? Do you? Inequalities, remember, are those less than, greater than statements. So we've looked at word problems where you're representing it with an equation, where that is, it's a statement that has an equal sign. Now instead it'll have a less than or a greater than sign. So for our first example, we have Chris wants to order DVDs over the internet. Each DVD costs $20 and shipping for the entire order is $10. Chris has no more than $100 to spend, and that first part is asking us to write an inequality that represents the situation. I went ahead and circled inequality because now that we've seen some word problems that ask for equations and some word problems that ask for inequalities, paying attention to what it's asking you to do is going to be really important. As soon as I see that, I know my answer should have an inequality sign, so a less than or greater than sign. If we look at the story we were given, this is pretty similar to something I gave you guys in those equation word problem notes. The difference here is he has no more than $100 to spend. With the equations, it was like he has exactly $100 to spend. So this right here is cluing us in on it being an inequality. The first part to our inequality, though, is really similar to what you already did with equations. We've got each DVD costs $20, so he's paying $20 for every single DVD, and shipping for the entire order is $10. So for him to get all these DVDs shipped to him, he has to pay $10 for the whole order. And we know he has no more than $100 to spend. We want to start off by showing he's spending $20 for every single DVD. He's spending $20 times the number of DVDs he orders. We don't know how many DVDs, so I could use a variable. And just like with those equation word problems, we're going to define our variable. So we're going to say, what does D represent? We could say DVD, but you want to be as specific as possible, because it might be the cost of DVDs we don't know. It might be how many DVDs he's buying we don't know. In this story, we know the cost. We know it's $20. What we don't know is how many. So we'll say D is our number of DVDs. So he's spending $20 times how many DVDs he buys. He also pays $10 for shipping. So I'll go ahead and say plus the $10 for shipping. Do I need a variable there? Maybe like S for shipping? Well, the shipping is a one-time thing. He's only paying it once. We're not multiplying it by anything, so you don't need a variable. Here you need a variable because he's paying it he's paying the $20 for every single DVD he buys, something that's happening more than once. So you'd be multiplying it by how many DVDs? This is just a one-time thing, so no variable. We also know from the problem, on my other side is going to be that $100. He has no more than $100 to spend. I would say that a lot of this, what we have so far, is very similar to what we were doing with the equation word problems. And like I said, the difference today is there's going to be an inequality sign here. We have to decide first, do we want a greater than sign or a less than sign to go here? Do we want to say this is greater than $100, or do we want to say this is less than $100? Well, they tell us he has no more than $100 to spend. This is what he's spending money on. He's spending $20 on each DVD. He's also spending $10 for the shipping. we want him spending less than what he has. He can't spend more than $100. It literally says no more. No more than means less than. The money he's spending needs to be less than 100. Now when it comes to less than signs, you have two options. You can say less than, and you can say less than or equal to. We have to decide, do we want this to be a less than sign or a less than or equal to sign? Well, again, it's going to go back to what this is saying. This is saying this is the money he's spending. The money he's spending can be less than $100. He could also spend all his money. He could spend equal to $100. So we want to use less than or equal to. If he can spend no more than $100, that means he can spend $100, which is the or equal to part, or he can spend less than that. So this right here would be our first part. That would be the inequality that represents this story. Now for the second part, how many DVDs can he order without exceeding his $100 limit? Well, again, it's real similar to what we were doing with the equation word problems. We've got this handy dandy inequality here. We can go ahead and solve it. You could also figure this out with like guess and checking, like if he buys 6 DVDs, is he okay? If he buys 2 DVDs, is he okay? And doing the math. But since we've got this, let's go ahead and solve it to get our answer. We've got 20D plus 10 is less than or equal to 100. I'm just copying it down. Go ahead and see if you can answer this question. Okay. Well, to solve, we're subtracting our constant, which is that 10, and getting 20D is less than or equal to 90. The next step is dividing out that 20. Fun fact, 90 divided by 20, you can cancel the zeros. So if there's 2 zeros here, I could cancel 2 zeros down here, 1 0, 1 0. It just says that 90 divided by 20 is the same thing as 9 divided by 2. Maybe that math's a little easier for you to do. When you end up dividing those, we could leave it as a fraction, but we're talking about DVDs. I'm not going to say 9 halves DVDs. If you divide it out, you get the decimal 4.5. Now, just like we saw with the equation word problems, we've got the same problem here. It's talking about DVDs. You can't buy 4.5 DVDs. So similarly to what we did back in the equations, we've got to figure out in this problem what makes sense. Yes, I know 4.5 rounds up to 5, but we got to figure out based on this problem, does it make sense to round up or round down? Well, we're saying he has $100 to spend. He can't spend more than that. If you round up to 5, that would be 5 DVDs. More DVDs means he's spending more money. It would mean he's spending money he doesn't have.
Pardon the interruption. Can we get a custodial staff member to the main office, please? Custodian to the main office, please.
Sorry about that. So if he rounds up to 5, that would be money it would be more DVDs he's buying, which would be money he doesn't have. We need to round down to 4 DVDs because he could afford 4 DVDs, right? That's staying within his budget. So our final answer, how many DVDs can he order? He could order 4 DVDs. The other difference is because this is an inequality, he could order 4 DVDs. That's the most he could order, but he could also order less. So we're gonna say he could order 4 DVDs or less. He doesn't have to spend the maximum amount of money, right? It's just saying how many could he order. He could order 4, he could order 3, 2, 1, 0. If he decided he didn't like any of them, those are all options. I think the nice thing with the inequality word problems is if you do get a decimal and have to round, this inequality is gonna help you know which way to round. This is saying D has to be less than 4.5. Well, that less than sign is telling you you've got to go down. So as long as you've got the right inequality sign in your word problem, that should help you know which way you want to round for the answer. So this is the example I have. The next one is going to be one for you to try. I'm going to have you answer the first part, just write the inequality first to make sure we're all on the same page, and then I'll have you try the second part. So your question says, Robin's son sells lemonade on the weekends. He sells each cup of lemonade for $2, but it costs him $9 to get all of the supplies. He wants to make a profit of at least $20. Write an inequality for the amount of cups of lemonade he needs to sell in order to make at least $20 for a new toy. Go ahead and do this first part now. Well, what did you have for your inequality? You want to show that he's selling each cup of lemonade for $2. So I would have 2. Now, if the problem doesn't give you a variable, you can choose whatever you want. A lot of people, when we do this in class, use the letter L. But notice it told us what variable they want us to use. They're giving you C. So we want to make sure we're using C there. I also don't have to define C because they've already defined C as the amount of cups of lemonade he needs to sell. So we got 2C. It tells us it costs him $9 for all those supplies. Costing him money is money he's losing, so I want to subtract out that 9. And then he wants a profit of at least $20. Well, I know 20 is going to go on this side. This is the money he's making, right? He's making $2 for each cup of lemonade, but he has to take $9 out of the money he makes. So this represents how much money he ends up with. We want him to end up with at least $20. Sometimes that word least is tricky because it looks so close to the word less, you just are dying to put that less than sign. But if I will say I want at least $20, that means I want $20 or more. So I want to say he wants to make greater than $20 or equal to $20. I say I want at least $20, that means you're okay with it equaling 20. So this would be our inequality for the first part. What about the second part of the question? The second part says, how many cups of lemonade does Robin's son need to sell? Go ahead and try that now. Well, our inequality is 2C minus 9 is greater than or equal to 20. You could come in and add 9 on both sides, which leaves you with 2C is greater than or equal to 29. You then would divide both sides by 2, and it leaves you with C is greater than or equal to 29 halves. When you divide that out, that gives you 14.5. Did you say 14.5 cups? I hope not. You can't sell half a cup. So we're going to have to choose which way we want to go. Which way did you go? Well, it's a greater than sign, so I want to round up. I go up to 15 cups. Selling more cups of lemonade means he's making more money. That's going to get him to at least $20. If you go down to 14 cups, that would mean he's not reaching his goal. If I ever asked you to prove to me that this is the right answer, you could support your answer by solving. Do you know what else you could do to just confirm, like, this for sure is the correct answer? Well, you've got some options. You could substitute this back into your inequality, or you could just go back to the original problem, right? Forget you're in algebra class for a second. If I told you about Robin's son, and I told you he sold 15 cups, if I asked you how much money he would make, it's just like a multiplication problem, right? 15 cups, well, if he's selling them for $2 each, 15 cups times the $2 each means he's made $30. But remember, he spent $9 for the supplies. That leaves you with $21. So if he does that, yep, he made at least $20. So to answer the question, how many cups of lemonade does Robin's son need to sell? We're going to say 15 cups. I'm going to erase this to add something in. Do you know what I want to add? He wants to sell 15 cups or more. Right? 15 cups is the minimum he would need to sell, because that's the first amount where he would end up having at least $20. But if that kid sells 1,000 cups of lemonade, props to him, but it would mean he definitely gets to that goal of $20. So 15 cups or more. This example, like I said at the beginning, is very similar to what we were looking at with our equation word problems. And a lot of these inequality word problems are going to be familiar because they're just really similar to the equations. It's just a difference of, instead of an equal sign, you're using a less than or greater than sign. I have 2 other examples I'm going to look at, and they're examples that, in my opinion, are different from what you've already seen. So the next one says, Alice decides to start a t-shirt company. She buys a t-shirt printer for $200. It costs her $5 to make each shirt, and she will sell them for $12. How many t-shirts does she need to sell to make a profit? And again, that first question is write an inequality. Write an inequality to show how many t-shirts she should sell. Now they're giving us a lot of information here. Let's start going through it. We're trying to find how many t-shirts she needs to sell to make a profit. So we're trying to figure out something to represent the money she's making, right? Well, the very first thing she did is she buys a t-shirt printer for $200. It's money she spent. So it means the very first thing she does is she puts herself in the hole, $200. She's starting off, you have to spend money to make money. She started off by spending $200. I'm using a negative sign because if she doesn't end up selling a single shirt, she ends up losing money. She's lost $200. So how is she making money? Well, we are told that it costs her $5 to make each shirt. That's still not money she's making. It's costing her, so that's still money she's losing at this point. She spent $200 on the printer, and she's spending $5 to make each shirt. So every single time she makes a shirt, she's spending $5, I'm guessing on the supplies, right? So we want to come in and say, she spent the $200 and she's spending $5 on each shirt. So that's something that's happening again and again. I need a variable in there. And we could say S is just the number of shirts. The number of shirts she goes to make. So she spends the $200 on the printer. She spends $5 on every single shirt she makes. Well, when is Alice going to make money? Well, it says she will sell them for $12. So that is where the money she's making is coming from. Every single time she sells a shirt, she makes $12. Well, we finally got to the part where she's making money. So I could say, this is all the money she spent, but then the money that's going in her pocket is $12. What's each of those shirts for $12? So every single time she sells a shirt, that's bringing $12 into her bank account. So $12 times the number of shirts. Notice here I'm using the same variable. I'm using the same variable because both of these are talking about shirts, right? She's losing $5 on each shirt for the supplies, but then when she sells it, that gives her the $12. So they're both about shirts. Well, what's her goal? Usually in a lot of these problems, they tell us a specific goal. So like in that last one, Robin's son wanted to make at least $20. Well, we would have the $20 here. Or in the first problem, can't remember what was happening in the first problem, but maybe like I remember. You have a total of $100 to spend. That one right here. Well, did they give us that? They didn't give us a number. Instead, they said she's trying to make a profit. Make a profit. Well, what does it mean to make a profit? What number does that translate to? If you want to make a profit, let's say after she pays all the stuff and makes her money, she walks away with $5. Is that a profit? Yeah, because she's paid this off, she's made her money. After doing all of that, she walks away with $5. That is a profit. That's money she's walking away with. It's not a good profit, but it is a profit. Well, what about $1? Still a profit. $0? If you walk away with nothing, that's not a profit. That's you breaking even. So if she wants to make a profit, what are we describing there with $1 or $5? If she walks away with $1,000, we're just describing positive numbers. The way you could write that is you want to say she wants to make more than $0. Any positive number is greater than 0. So after she does all this, she walks away with more than $0. That would be a profit. Now when we talked earlier about like the greater than sign, we said you've got two options, greater than or equal to. Do I want to use a greater than sign here or a greater than or equal to sign there? Well, if we put or equal to, that means after all the dust has settled, she's paid back for all the stuff she spent money on, she's got her profit from the $12 for each shirt. If it equals out to be $100, that's not a profit. Remember, we said that's breaking even. So in this problem, I don't want to say greater than or equal to, I just want to say greater than. And this is one inequality you could use to represent this problem. Now, when students read this, depending on what you're thinking as you're reading through it, you might be thinking of something different than this. And that's okay, because there are other options for this. And I'm gonna talk through them one at a time as we start to solve this. One of the things I've had students in the classroom say as we read through this is they say, well, it cost you $5 to make each of the shirts, but you're selling them for $12, so that really just means you're making a profit of $7 on each shirt, right? Do we have to do all of this? Can't I just say you're making $7 for each shirt? Well, if I went to solve this, what's one of the first things I could do? Well, I know I personally, when I see terms I can combine, I would want to do that. I would want to come in and say, let's combine these two things and say negative 200, negative 5s plus 12s, that gives you a positive 7s. And then I'm just going to copy down my greater than 0. So this right here is another option, and it says exactly what I just said a moment ago. Saying you're still setting the $200 on the t-shirt printer, but I'm just combining this information of it costs $5 to make a shirt, and you're selling them for $12 each, to say that just means you're making a profit of $7 on each shirt. So if you were thinking that at any point as we were going through this, that's also an option. Now the other thing I hear students say is, well, making a profit means you're making more money than you're spending. And I agree with that, right? If you make more money than what you've spent, that's another way to think of a profit, instead of saying making, like walking away with more than $0. So sometimes students say, well, that 200 there, that's money she's spending. The $7 on each shirt is where she's making money. Why can't we just say we want the money she's making to be more than the money she's spending? Well, you can. The next step to solving this would be bringing that constant over to the other side. So I'm going to go ahead and say plus 200 plus 200. It's going to say 7s is greater than 200. It's saying exactly what we just said. Another way to think of profit is the money you're making, which remember, she ends up making $7 for each shirt. The money you're making needs to be greater than the money you spent. Now the one warning I have about this one, if you try jumping right to this after you read the problem instead of doing these steps, is notice here that 200 isn't negative. It's negative if you're putting it on this side with the money you're making, just to show negatives means that's money you've lost, positive means it's money you've made. It's all on the same side, it needs to be negative. Here in this situation, we're just saying the money you make needs to be more than the money you spend, which is why I showed these other ones first. These are all good options. It's just however your brain works at the end of the day. I've written on top of our second part of the question, but I will read it to you. The second part says, how many t-shirts does she have to sell to make a profit? We've already done a lot of the solving, so you've got a head start. But go ahead and see if you can answer that question. How many t-shirts does she have to sell to make a profit? All right, well, the last step, because there's only one last step, is to divide both sides by 7, which would leave you with s all by itself. I do not know what 200 divided by 7 is off the top of my head. 7 goes into 20 twice. That's 14, so it would leave you with 6. And then 7 goes into 68 times, which would give you 56, so remainder 4. Just like some of the others, that gives you a decimal. 7 goes into 45 times. So we're getting a decimal 28.5, around there. So we've got S is greater than 28.5. We're talking about t-shirts, so you can't sell a decimal t-shirt. Every now and then there will be a problem where you can write your answer as a decimal, by the way, which is why I'm always going back and checking what the question's asking for. Here it's asking for t-shirts though, and t-shirts, we cannot sell decimal t-shirts. So we've got a round. Which way did you go? Well, it does say here that our number of shirts, the number of shirts needs to be greater than 28.5. Since I know it has to be greater than this, that's telling me I need to go up. I'm gonna say 29 shirts. If you go up, more shirts means you're making more money. That's gonna help make sure you make that profit. So we could say, how many t-shirts does she have to sell? Well, she has to sell 29 t-shirts. Did you do it? Or more, right? Who is this? If Alice sells 1,000 t-shirts, obviously she's gonna be making that profit, which is why we tack on that or more part. Hopefully this problem makes a little more sense now. So this is my example. You've got one to try yourself. That is fairly similar. I'll go ahead and erase all this. The first part says, Adinka opens a bakery to sell cakes. She pays $500 to rent the building. She wants to sell each cake for $20, and it costs her $4 in supplies to make each cake. How many cakes does she have to sell to make a profit? So again, the first part, go ahead and write an inequality that represents the situation. Okay, and then the second part, how many cakes does she have to sell to make a profit? All right, there is one last example. And our last example looks like this. In this last problem, we've got Samuel can choose from 2 membership options at a movie rental store. Option A has a yearly fee of $50, and every movie rental costs $2.50. Option B has a yearly fee of $75 for unlimited movie rental at no additional cost. This is a lot of information, so usually in class we just pause here to summarize what this is saying. Saying we've got Samuel and he's got 2 options. For option A, what are you paying? On option A, you pay $50. How often do you pay $50? Well, you pay it once. It's a yearly fee. So once during that year, you pay $50. Do you pay anything else? Well, yeah. Every single movie is going to cost you $2.50. So you pay the $50 at the beginning, and then after that, each movie is just $2.50. So that's your first option. Your other option, option B, what do you pay for option B? Well, we've got a yearly fee of $75. How often are you paying that $75? Once. So again, it's a yearly fee. So just like this one was $50, this one's one time $75. Do you pay anything else? Well, for this one, no. It says unlimited movie rental at no additional cost. So this one you pay less at the beginning, but then you're paying for every single movie. This one you pay more at the beginning, but then you don't ever have to pay anything again. So before we get into all of this, just like a quick check here. If I was going to rent one movie, first of all, if it was only one movie, this is a silly thing to do. But if I only rent one movie, if I'm not renting many movies, which is going to be the better option? Well, option A, because I'm paying less at the beginning, and I'm not going to end up paying this enough times to make this be a better option. Right? For option A, if I'm only renting one movie, I'm paying $50 plus the $2.50, which is going to be less than the second option. If I rent 1,000 movies, 1,000 movies, which option is better? Well, if I'm renting a ton of movies, this is going to be the better option, because if I was renting 1,000 movies, $50, and then paying this for 1,000 movies, paying this every time 1,000 times, is going to be way more expensive than just paying this once and never paying again. So you can kind of like briefly see here, I didn't do any math, it was just kind of hypothetical situations, but you can see if you're not going to rent many movies, this is a really good option. Well, I don't know if it's a really good option, but it's the better option. If you're going to rent lots and lots of movies, this here is the better option. Hopefully we can agree with that. So I say all that to say, when we get into this part here, It's asking us write an inequality for how many movies Samuel would need to rent to make option B, the $75 one, cost less than option A. So we're looking, where's that point where it tips? We said if you're not getting a lot of movies, A is better. If you're getting tons and tons of movies, B is better. At what point does it make sense to switch over to the other side? So that's what we're trying to do in this problem. When it comes to writing this inequality, sometimes students really struggle to see like where the number should go. So my advice for these is I'm just gonna write this out kind of like a template for my inequality. What I'm trying to do here is I want option B to be less than option A. I'm just writing down what they said using math, using algebra. So we got B is less than A. Well, now let's fill in what we know. Because we already said earlier, option B, what are you paying for option B? Well, we already said you're paying $75 one time, nothing else. So instead of saying option B, I'm gonna say what we're paying for option B. You pay $75 one time, nothing else. I'm not adding in anything else. So we want option B, which is the $75, to be less than option A. Well, what do you pay for option A? We said earlier, option A, you're paying the $50. Pay that $50 one time. But you are also paying $2.50 for every movie. So you pay the $50, but you also pay $2.50 every single time you rent a movie. So I'm gonna say $2.50 times the number of movies. I think having this, as silly as it seems, I think this really helps you know exactly where all these numbers are gonna go. So that's how I get to this first part, our inequality. Now remember, we were writing this inequality to figure out where's that tipping point. Where does it make more sense to get option B? Where does option B end up costing less than option A? At how many movies? Well, the second question is asking, what is that minimum number of movies he would need to rent in 1 year for B to be less than A? We had said at the beginning, if you're not getting a lot of movies, A is the better option. If you're getting a ton of movies, option B is the better option. At what point, what's that minimum number that makes this one the better deal? So that's what we're trying to find. Well, now that we've got this inequality, all we have to do is solve the inequality. So I've got 75 is less than 50 plus 250m. Go ahead and try solving this inequality. Well, we want to subtract 50 on both sides. That leaves us with 25 is less than the 250m. I hope I'm not going off your screen. But I'm dividing both sides by the 250. So we get, I'll put it up here. So we get 25 divided by 250 is 10. I'm just gonna copy down that less than sign. So we get 10 is less than M. And I'm just gonna do the same thing we did in the graphing inequalities. This is fine, but I'm gonna flip it around so that variable comes first just to make it really clear what our answer is saying. So instead of saying 10 is less than the number of movies, I'm gonna flip it around, and when you do that, your inequality sign changes. 10 is less than M is saying the same thing as M is greater than 10. So we've got M, the number of movies, is greater than 10. So if I ask you, what is the minimum number of movies, what would you say? Well, oftentimes in class, everyone goes 10, and I say no. Because M, remember, is the number of movies. So it's saying M, the number of movies, needs to be greater than 10. So if we tell them to get 10 movies is not greater than 10. It's equal. The minimum number, there are lots of numbers of movies he could get that are greater than 10. Remember the example I said at the beginning, he could get 1,000 movies. But the minimum number of movies he could get would be 11 movies. That is the minimum number, the smallest number, that is greater than 10. Now, I understand if you're watching this video and you're like, what did she just do? I see the number 10, why is she saying 11? Let's just pause for a moment and go back to what the problem's saying again. Because remember, you can make your answers make sense. You can check them by going back to what the story is saying and just use some of that common sense I know you guys have when it comes, especially to money. If he rented exactly 10 movies, if you really badly want to say the minimum number of movies to make B cost less is 10, let's figure out how much it costs for 10 movies. Option A, 10 movies for option A would cost the $50 plus the $250 for each of those 10 movies. So plus the $250 times those 10 movies. $2.50 times 10 is $25. So $50 plus $25. Option A is going to work out to be $75. Well, 10 movies for option B is $75. So if you were saying the minimum number of movies he would need to get to make B cost less than A is 10, 10 isn't going to make B cost less than A. 10 is going to make it not matter which option you go with. However, remember the number of movies needs to be greater than 10. If we go up to 11 movies, well, this is still going to be $75. But if you add on one more movie over here, that makes A cost more. It'll make B cost less. That's that point where it tips and makes B the better option. It makes B cost less money. My advice, especially for these word problems, equations, and inequality, sometimes it can be hard to reason with some of these answers. Go back to what you guys know. You can always do the math out like I just did here to confirm your answer is correct. This is my last example. I've got one last one for you to try. Let me erase all of this. The last one says Luis can choose between Verizon and T-Mobile for his phone plan. Verizon costs $75 each month for unlimited data, and T-Mobile costs $45 each month plus $5 per gigabyte of data. Write an inequality to find how many gigabytes of data Luis would need to use to make Verizon cost less than T-Mobile. Just gonna underline this here for you. Go ahead and try that first part. All right. The inequality we'd want to use if we want Verizon to cost less than T-Mobile, you would want your inequality to say Verizon, which is 75, needs to be less than T-Mobile, which is the 45 plus the 5 per gigabyte. So this right here is that inequality. Now that we've agreed on an inequality, answer our second question. How many gigabytes does he need to use each month to make Verizon a better deal? What do you think? All right. Hopefully you're feeling a little more confident with these inequality word problems. Remember, please reach out to us. We have tutoring hours every day that you could reach out to us during if you have any questions on some of these problems or the answer I put on the board still doesn't make sense to you. If not, I will see you in the next video. Thanks. Bye.